Hello friends, in this era of digital transformation, this term cloud computing is becoming more popular. The world is rapidly shifting toward this digital transformation, and the traditional on-premises IT environment are becoming insufficient, right? So cloud computing offers great eligibility, scalability, and cost efficiency. Here we will see the benefits of cloud computing. So that first benefit is instant access. So you can access the computing resources anytime, anywhere. Okay, so that means no needs to physical infrastructure or hardware. The second most important thing is scalability. It allows you to automatically adjust the quantity of resources based upon the demand, right? So ideal for the dynamic workload and growing businesses where we do not want to manage everything. Instead, as per the demand, our resources get allocated, right? Next is cost efficiency. So it's eliminate the need for the expensive hardware purchases. You will only pay for that which you had used. Okay, so you do not need to pay for everything. And the other thing is accessibility to advanced technologies. So cloud basically makes it possible for augmented reality, machine learning, or AIs, or that other cutting edge technologies. So because in all these technologies we required a lot of resources, right? So cloud computing make it possible to even operate this AI, ML, or AR directly from your machines, or it can be you can operate it anywhere, right? So that empowers that empowered the individual and the businesses to innovate, right? The purpose of this whole scenario, like whole tutorial, is to understand this what is cloud, right? The second thing that we are going to understand here, what the cloud services does or offer, how secure it is, and how to manage it, right? So these are the 4 points that we are just going to understand, right? So what would you basically expect from this course, right? So in this course, we start with the introduction. So within that introduction, we will see the overview of the course structure and that objective. Then we will set the foundation for understanding the cloud fundamentals. And then we emphasize the theoretical part, not exactly that hands-on practices in this tutorial. So this is going to be a theoretical overview of the different services, or what basically this cloud service is, and what are the different models that we have to understand. Okay, so in the second phase you will understand that what are the different cloud models that operated by any basically cloud services, or maybe in more specifically to Azure, right? So within this Azure you will find three kinds of services. One we call as IaaS, right? Second one is PaaS, and third one is SaaS. Okay, so first one is infrastructure as a service, second one is platform as a service, and the third one is software as a service. So we will go through all of these one by one. Okay, and there we need to also understand that each of these models works on that shared responsibility model. Okay, so we will also see what is this shared responsibility model. Then onward, we will try to understand the different types of computing that we have. This includes this public cloud, private cloud, hybrid clouds, and sovereign clouds. Okay, so we will going to understand all of these one by one. Next phase, we will also going to understand like what is these terms which we often use in cloud computing. That is scalability, elasticity, high availability, fault tolerance. So these are more technical terms, but we will going to understand each and everything, right? And then onward, we will also get a high level overview of securities, management, and governance in cloud environment. Okay, so at last we are just going to get a recap of whatsoever we had just learned, right? So these all topics are going to be covered in this video, right? So if you are not aware of these, this video is for you. And if you are well aware of all these concepts, maybe you can target the next one, right? So for whom this course is, so this course is for all who are beginners in IT, or even though those experienced professionals who wants to understand like how these cloud computing actually works. It will also going to be helpful for the for one who is involving in making the business decisions, okay, and he or she wants to willing to know like how these how we can adopt, whether we are required to adopt this cloud adoption cloud technologies or not, and how these everything in clouds actually works, right? And if you are in a senior management position, even though if you are just willing to seek the knowledge of this cloud computing, what it is, and what are the different opportunities that this cloud computing offers, so in that scenario also this course will be helpful for you, right? So what basically is the pre-requirements? So a basic knowledge of computers, a basic knowledge of networking, a basic knowledge of storage, and some applications, okay. So there is not much, even though if you have a little knowledge of all these, that will be more helpful to you, right? So now we need to start with the first module, where we are going to understand what is cloud computing, right? So why when we call this cloud computing, so what exactly this cloud refers here, okay? So when we say like cloud, this cloud is like the cloud in the sky, right? So like in a sky there are unlimited clouds, so in a same manner, in an unlimited cloud we have unlimited cloud computing resources, right? So when we blend both two, right, so blend together to form a large units. So basically if two or more clouds are combined, they can form a even large cloud, right? A bigger cloud, right? So when two bigger clouds get combined, they will form even more bigger clouds, okay. So they basically, either these cloud could be fragmented in a like small clouds in a sky, or that can be combined to create a large cloud, okay. So this is the meaning of this cloud, that means here, okay. So either they can blend together or can be fragmented in a smaller units, so as per our need, right? So clouds appears to be extended infinitely but that virtually limitless, right? So if someone is going to ask you like how far you can see the sky, or how far you can see the clouds, okay, so if you just see like watch the sky itself, it is limitless, okay. So what are the core definitions that we had to understand? So this cloud computing is the is the delivery of this computing resources, okay. So what basically this cloud computing is? Cloud computing is the delivery of the computing resources from that IT stack as a service by the cloud service provider, right? So if even though if you do not understand what it is, no issue, we will understand it, okay. So let's start with how the traditional IT companies or IT stacks, I mean this, when we say that traditional, that means if we just exclude the cloud services, then without cloud services, how the traditional IT setup works, okay. So that setup what we known as on premises, right? So in on premises, business basically rely on the critical applications. For example, let's say we have these applications, let's say some of the applications is related to banking, healthcare, airlines, airline ticketing, or there are so many different applications, okay. So in these scenarios, if some business are in such business, if any of the like if we requires this IT solution for these businesses, and we are just managing everything in a traditional way, I mean on location, so what that like what are the what different things that organization have to maintain? So they need to maintain the expensive hardwares, which includes the server, storage, and network devices, right? They also need to handle this redundancy, I mean this power cut or cooling or internet kind of thing, okay, that it's continuous supply of this internet. They also need to um, maintain the secure physical state spaces, right? Which also requires real estate cost. They also need to handle their operating system, which includes this licensing and management. They also have to handle the frameworks and runtime environment, okay, for the application, and they also need to manage the data management and securities, both physical and digital, right? So all these different things have to managed by organization itself, right? So this is what we called all on premises setup, where everything is built and maintain in-house, right? So let's say if you just want a real life example, you can take an example as cake as a service, right? So let's say you want a cake, right? So if you want a cake, so then you need to also bake it by yourself, right? So baking requires effort, baking requires tools, baking requires ingredients, and everything that needs to be bake the cake or to make a cake, right? So ordering cake from the store is like using cloud service. Okay, instead if you want to eat cake, instead of making or baking, like purchasing all the tools or setting up the kitchen and everything, instead what you simply do, you simply go to a store and just place an order that you want a cake, right? So this scenario is what we call as cloud service. Okay, so in cloud service we do not have to manage each and everything by yourself. Instead you can simply place an order and you will only get, and once the and you will get what you ask for. Okay, so for that you just need to pay a little amount, right? So you get what you want, but without any hassle. Okay, so so this is what we call as when we talk about a store which is making the cakes, and you are just asking for the cake itself and paying the price. That is such kind of service what we call as cloud service providers. Okay, so the key insight is, if you do not want to bake your own cake every time, why build your own IT stack? Okay, when you can consume it as in service, right? So the key characteristic of cloud computing is resource pooling. That means computing resources can be dynamically combined or split. As per your requirement, if you want more resources, you can combine different resources into one. If you want less resources, you can basically split the resources into smaller units, right? That second advantage is scalability and elasticity. That means easily scalable resources up and down based upon the demand. Okay, so if the demand's up, if any certain time demands comes in, a huge demands come in, or let's say a huge traffic comes in, you will borrow more hardwares, right? So as the demand drops, you will remove those extra hardwares. Okay, now that third and the this is actually the most important advantage of cloud computing is it gives you that global accessibility, right? So that means that application can be accessed anytime, anywhere across the zones. And the next one is cost efficient. How it could be cost efficient? Because it's avoid the upfront investment in the hardwares. So if you need that hardware, you are paying for it. If you don't need that hardware, you are not paying for it. So that is why it is following a pay as you go model. Okay, so you will only pay for that what you are using, right? And the fifth point is focus on what matters. That means businesses prioritize the application and the data, not the infrastructure. Okay, so then business do not have to do that hassle around like managing every hardwares by themselves, right? So what's the recap that what we had learned is when we say is this cloud service provider, that simply means that entity or that organization that offers this cloud computing resources as a service is known as cloud service provider, CSP, right? The second one is what is Azure. So Azure is that microservice cloud service platform. Okay, so Microsoft basically offers like build an organization which offers these cloud services, and that organization what we name as Azure, right? What is on-premises? On-premises means traditional IT setup where we have to manage everything in-house, right? Now the next concept we have to understand here is virtualization. So what is virtualization? So virtualization means the foundation of the cloud computing. Okay, so basically let's start with what is virtualization. So virtualization is the core technologies that power cloud computing. So without virtualization, cloud computing would not be possible. So let's try to understand. Like every computer system consists of some physical components, right? So and that physical components includes this CPU, what we know as processor, this memory, what we call as refers as the RAM, and some hard disk, right? So we need these three resources to operate any computers, right? So these are real tangible hardware components, right? So what is what virtualization does here? So virtualization basically creates a software based virtual version. Okay, so that means we are not basically directly holding or managing these processors, CPU, RAM or storage. Instead, we are buying these CPU, RAM or storage virtually, right? So as same as in software, right? But basically these CPUs, memory and storage are operated by some other company. Instead, just you are renting these resources virtually directly, okay, by your computer. Okay, so virtualization creates a software based virtual version of this physical component, which includes virtual CPU, virtual memory and virtual storage. So these virtual components behaves identical to the physical counterpart but are not physical in real, right? So in real you do not have to manage everything, you are managing everything virtually, right? Virtually means simple, by internet, right? So why virtualization matters for cloud? So the reason is mobility of resources. So physical hardwares cannot be transmitted over that network, right? That is for sure. So but virtual resources can be provided over the internet. Okay, so that enables the cloud delivery, right? And that second point is enabling the cloud computing. What does it mean? It simply means that cloud computing is about delivering the computing resources as in services, right? So as in service, you are using these computing resources, right? So virtualization makes this delivery possible by decoupling the resource from that physical hardware. Okay, so that means you do not have to present at the where this hardware are present, this physical hardware are present. Instead, you could be anywhere in the world and these resources could be anywhere in the world. Okay, so this is what we call as decoupling, right? So this gives you the ability of this decoupling. The second concept that we have to understand here is isolation and independence. So virtualization provides isolation between the different virtual instances. So what does it mean? It simply means that let's say let's try to first read this point. If it is not clear, then I will try to make it understand for you, right? So virtualization provide isolation between the different virtual instances. Like each virtual machine or the resources operate independently. One virtual machine is unaware of the other on the same physical system. This ensures the security, scalability and resource control. Okay, so if it is not clear to you, let me try to make it more clear. Since in virtualization, basically what is happening, they are not just buying, let's say this is a storage unit, okay, or let's say this is a RAM, right? So this RAM is not just a 5 GB or 2 GB RAM, right? So maybe this RAM is 1 TB RAM, okay? It's 1 TB RAM, right? So now you are not going to use for your use cases, it is not required this 1 TB RAM, right? So basically what is happening there, instead of assigning this completely 1 TB RAM to one user, right? It is assigning, like it is dividing the RAM into parts, right? So now you can say this is 5 GB RAM, 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 right? So now your requirement is 5 GB RAM only, right? So it allocates this one unit of RAM to your memory, so like to you, right? So if you require like 2 units of memory, I mean this 10 GB RAM, so in this case it will allocate 2 units of this memory, right? So what is the, so this is what we refer as each virtualized machine or the resources operate independently, right? So that your concern could be, right, okay, so this unit is assigned to me, so then this 2 units will be assigned to someone else, then these 2 units will be assigned to someone else, right? But because of these all these like units which we are like dividing on like physically, it's so this is one RAM, right? So we are dividing like we are just allocating a different section or a different space in this memory, right? So how does don't a user who have the access of this RAM will also somewhere are going to get access of my RAM, like my portion of this memory? Is it possible? Okay, so that is that answer is it is not possible, right? Because they are managing everything in such a way, like if this resources is assigned to you, right, no one can get interfered to this resource, like what is assigned to you, right? So similar to others also. So if this resource is assigned to someone else, let's say A2, so this A1 have no access to this A2, right? So this is what we refer here as securities, right? Okay, so let's move here. So here it is written here, like virtualization provide isolation between the different virtual instances. Each virtual machine, that is VM, or that resource operate independently. One virtual machine unaware of the others on the same physical system. So this ensure the security, stability, and resource control, right? So what are the key takeaways from here? It is virtualization is the enabler of the. So what are the key takeaways here is virtualization is the enabler for the cloud computing. It allows the efficient resource utilization, scalable and flexible providing, and the secure multi-tenancy, right? So key characteristic of what are the key characteristic of cloud computing? So to quantify as the true cloud computing, a system must exhibit at least 4 essential characteristics, that is resource pooling, elasticity, pay-per-use, and automation, right? So what are these? So when we say like it should be a resource pooling, that means by definition combining a large number of physical computing resources and virtualize them into a shared pool, right? So user can require the virtualized resources of any size, small or large, based upon their needs, and applicable to all core components. That should also include this processor, memory, and storage. Inspired by the cloud analogy, blending and the fragmenting like cloud in the sky. Okay. The second one is elasticity. What does it mean? Elasticity means the ability to scale resources up and down based upon the demand, right? So that is what we call as elasticity. So cloud providers operate massive global data centers with virtually unlimited capacity. So user can basically provision more resources during the peak demand and deprovision resources when demand drops. So inspired by the cloud analogy appears to be extend infinitely. The third property for this cloud computing is pay-per-use. By definition, what you should understand by pay-per-use, you only pay for the resources you actually use and for the duration of uses, right? So unlike on-premises setup, there is no upfront investment in hardwares. Billing is usually based upon if someone used 2 units, you pay for 2 units. If nothing used, you pay nothing, right? So this is the promotion cost efficiency and the financial flexibilities. So this gives you the promotion cost efficiency, and this promotes the cost efficiency and financial flexibility. Next point is automation. So by definition, what it is? So all the above characteristic, resource pooling, elasticity, pay-per-use, are all automated, right? So what does it mean? So you do not have to configure everything, but it is being managed automatically without your configuration, right? So it enables that on-demand provisioning of the resources. And the second is self-service capabilities without needing to support for the provider. Okay, so self-service capabilities without needing support from the provider. So user can manage resources independently, enhancing speed and control. So as in summary, what you can see, to be considered as a real cloud, a system must have resource pooling, elasticity, pay-per-use, and automation. Okay, so now it's time to let's try to understand the different infrastructure infrastructure services that we have. Okay, so we first are going to start with this infrastructure as a service, right? So what is IaaS, right? So IaaS is the short form of infrastructure as a service. So infrastructure as a service is a cloud service model where the cloud service provider, that is CSP, offers virtualized hardware resources to the customer as a service. So these resources includes the virtual CPU, virtual memory, and virtual storage. So basically, who use IaaS infrastructure as a service? So customer organization. So they uses the customer organization, which requires the setup. SMBs, large enterprises consume these services. So most enterprise clouds are B2B, business to business. So why choose only part of the IT stack? So when we requires more control and the customization, in such cases we go with IaaS services, right? So what this IaaS infrastructure as a service provides you? So it gives you the control and customization. So customer can need to specify the configuration, that is which operating system or which operating features they are using, they are willing to use, what are the custom frameworks that they are willing to use. If such configuration is required in your application, you should go with infrastructure as a service, right? So in this, this infrastructure as a service, what are the responsibility of the cloud provider? So in this case, procure and set up the physical hardware is the responsibility of cloud provider. Virtualize the hardware, virtualizing the hardware is the responsibility of cloud provider, and managing the physical infrastructure needed. So that includes this redundant power, cooling, internet connectivity, physical space, right? All these are the responsibility of this cloud provider in this infrastructure as a service. Important note here we have is the cloud provider do not deliver the physical hardware, only the virtualized version that behave identical to the physical one, right? So what is customer control? So when we say here like user have this customer control, so what does it mean? It simply means that user have the control of which operating system they are willing to use, which patch and hot fixes they are willing to take, which frameworks and runtime they are willing to use, which application they are willing to use, what are the data or the database they are willing to use. So all these customization are now being controlled by the user itself, right? So this gives the customer the maximum control over the upper part of the IT stack, right? So what are the advantage of IaaS, right? So IaaS, so that advantage is this high control over the environment, flexibility to customize the operating system, frameworks, and application, and idle for the application needing specific operating features or the configuration. So what are the disadvantage of IaaS, right? So its disadvantages: more work to the customer. So customer have to manage a lot of work apart from the physical hardwares and cooling and electricity, all right. Apart from this, still customer have a lot of work to manage. He is responsible for managing and maintaining everything above the hardware layer, and that requires the technical expertise and operational effort, right? So decision criteria क्या होना चाहिए? So to determine if IaaS is right for you, we need to ask how much control do you need over the environment. So if you require like much control over the environment and the versioning and the operating system and everything, so in such scenarios you should go with IaaS. If it is not, then you should consider that other methods like other services which cloud services offer, okay, and how much works you are willing to take on. Okay, so if you are ready to take all of these control and managing everything like this operating system to patches and hot fixes, frameworks and runtime, application and data, so if you are just willing to manage each and everything, then it's good to go with IaaS, right? And second one, what we call as PaaS, right? So what this is PaaS means? PaaS is refers as platform as a service. Okay, so what is PaaS? Platform as a service is a cloud service model where the cloud service provider, that is CSP, delivers the application dependencies as a service. Okay, so these dependencies includes this operating system, patches and hotfixes, frameworks, and runtime environment. Okay, so these four things are now being managed by cloud itself. Okay, so you do not have to think about the which operating system they are using, which patches and hotfixes they are using, which frameworks they are using, which runtime environment they are using. Instead, you just need to understand that you are just giving its application and it is deployed. Okay, and you are not aware of how they are managing all these parts. Okay, so who uses the PaaS, right? Like PaaS, when we say like platform as a service, so that customer organization that develops the application in house, purchases the application from the software vendors, or want to deploy the application without managing the underlying platforms. Okay, so if someone do not want a lot of headache, okay, so instead his requirement is to just because of he had developed some application, he just want to deploy that application. Okay, so in that scenario he should use this PaaS. Okay, so in that scenario, all those securities, operating system, frameworks, runtime environment, they do not have to manage any of these things. These all are managed by the cloud service itself. You just need to give the code, set the environment variables, and voila, your code is now being deployed, right? So what the cloud provider handles here, so this cloud provider set up and maintain the operating system, security patches and updates, frameworks and runtime environment, right? So here you need to note, here we have a note that says that these components forms the platform layer of the IT stack. Okay, so this platform layer is now being managed by the operating system, right? So what are the customer control? So now what part of the application is now being controlled by the customer? So and that now this if you are using this PaaS, like platform as a service, here you just need to manage your application and the data, right? I mean that data is always with you. Okay, so this allow the customer to focus on building and running the application without worrying about the platform configuration. Okay, so what is the advantage of the PaaS, platform as a service? So the advantage are quick deployment of the application, no need to manage the operating system or the runtime dependencies, idle for the standard application environment, enable that fast deployment cycle, right? But what are the disadvantages? Does it have any disadvantage? Actually, it's not a big disadvantage. It's like less control over the environment compared to infrastructure as a service, and may not support the highly customized or legacy application. Okay, so when we say this legacy application, it simply means that your application basically let's say supports some node version, like some older node version only, right? Or some specific version of framework on and so on, right? So in such scenarios, maybe if it is the case that your application is built on some other some other technologies which is not there, or some other node frameworks which is not directly being supported, like which is not basically worked with your application. So in such scenarios you should go with infrastructure as a service, where you have every control. Instead, in most of the cases, in most of the applications, this platform as a service perfectly works fine, right? So decision criteria, what should be the decision criteria if you should go with PaaS or not? Does that application supports PaaS? So if it supports, if it support, then PaaS is the great choice. If it is not, then more control is needed, and then you should consider this IaaS, like infrastructure as a service. So PaaS is more popular cloud service model among the businesses due to its balance of conversion and control. Okay, it's conviction and control, right? So next point that we have to understand is, now we have one more model which we call as service, software as a service, that is SaaS, right? So what is SaaS? So software as a service is a cloud service model, which again cloud service provider, that is CSP, provides you. Okay, that drives the full functional application directly to the customer as a service. Okay, so the application is installed and configured by the CSP. So that installation and configuration and managing every storage and everything is done by this cloud service provider itself, and that application that it's delivered to the customer is ready to use. Okay, so customer do not have to anything, like he just need to just log in and use the software itself, right? So who uses this SaaS? Customer organization that needs the access of the popular ready to use application without managing the infrastructure or the platform dependencies or the software or that application. Just they need to do some activity, and that all those activities basically performed by any online softwares, you can say, right? So what are the cloud providers handle? So in this case, in SaaS kind of model, this cloud provider handle everything, you can say. Okay, so the installation and configuration, application, that application is managed by the cloud provider, operating system, frameworks and runtime, all the underlying dependencies. So everything is basically managed by SaaS, this this cloud service. So what we need to note here is SaaS offering are typically limited to popular high demand application. Okay, so that means this SaaS wala platform, this SaaS wala service is not just applicable for anyone, right? So it is basically available for that which have a lot of requirement. As you can see, like maybe you are aware of this Canvas, right? So you can say Canvas is an a SaaS kind of application. Okay, so where you just need to log in and you can make your logo, create your designs, create your presentation, everything, right? In the same way, this Microsoft 365 Excel, so this is also a SaaS application, right? So what are the so here what are the customer control? Okay, so the data generated by the application is what is controlled by the customer. So user access the basic configuration, whatever is needed. Okay, so this login credential, where that user have this this username and password, and there all, and he have the access of all that data that he had produced, right? So that much level of access this customer have based upon this access credentials, right? What are the advantage of SaaS application? So that minimum setup is required, fast deployment, application is ready to use, no need to manage the infrastructure or the platform both, right? And ideal for the non-technical users or the business teams, so they do not have to know anything about the coding and how like different pieces of the code is written, what is the bug and what is the, if there is bug or not. They just need to just log into that application and simply ready to use. Okay, so what are the disadvantage of SaaS application? It's limited application availability. Only popular applications are offered by the CSP, like cloud service provider. So those popular application which is like in demand for, like, let's say millions of users. Okay, so such applications is basically operates on this SaaS model. Okay, so niche and the customer specific application, so niche and the custom applications may not be available there, right? So cloud providers focus on the application that generally generates a high demand or that revenue. Okay, so what are the decision making? So to determine if that SaaS is right for you, is that application you need available as an SaaS offering? Okay, if yes, then SaaS is the best choice. If not, consider PaaS or IaaS. IaaS, right? Infrastructure as a service. It simply means that if, let's say, you are willing to build a new Canva, right? But you understand that the number of features that Canva provided, or that number of features that Excel 365 or that Office 365 provided, right? So so there is no meaning to put a lot of effort to rebuild all of this thing, right? Instead, you should go with this SaaS model. Simply get a login credential and use the service directly, right? So there is no need to do all that hassle, right? So that is so in such cases, if some SaaS application is there and it is ready to use just by paying a little amount, okay, so in those cases you should definitely go with SaaS application. That will be the best choice. If it is not, then you should consider to either a platform as a service model or this infrastructure as a service model, right? So now we need to understand here so all of the cloud services are operates on a principle that we call as shared responsibility principle. Okay, so what does it mean basically? So when we say this shared responsibility principle, it's simply like two-wheel cycle. Okay, so there is just an analogy that a cycle have two tires. Okay, so it have to balance on both. So just like both wheels of the cycle works together to balance to balance the smooth riding, cloud computing involves the two parties. Okay, so one party is the cloud service provider, that is CSP, and the second party is the customer. Okay, so both share responsibility for the application uptime and the security. Okay, so it is not just that if let's say if let's take an example of the SaaS application. Okay, and here we have a Canva. Okay, so this Canva have an user credential. Okay, so if you by mistake not handle your credentials with safety, okay, so it not the responsibility of the cloud service provider for your losses. Okay, if someone get into your system and like make any changes or delete something, right? So that loss is not being covered by this cloud service provider, right? So you both as in customer who are using this software, maybe if you are just using this platform as a service or infrastructure as a service, in all the C3 scenarios you also have the responsibility of the data at the customer side, right? So both have the shared responsibility for the application uptime and security, right? So why shared responsibility matters? Because it prevents the confusion and ensures the efficiency. So clarity defines who is accountable for which part of the IT stack, right? So this so when we basically defines that who is responsible for which part, then it is it's more easy to track like where something happens wrong, right? So in IaaS, infrastructure as a service, in platform as a service, in software as a service, in all the three places we have like different accountability for both parties, customer and cloud provider itself, right? So let's say this baseline on-premises environment. Let's say if we have this on-premises environment, that means everything is managed by like customer itself, right? Both that physical storage, also there's power, cooling, internet, hardware, operating system, patches, frameworks, application and data, securities of the entire stack. Okay, so if in such case, if you are handling everything on premises, right? So in such case, you are customer is solely responsible for everything from the physical software, like from the physical space to cooling to internet to the electricity to hardware to operating system to frameworks to application data to the security of the entire application and everything, right? But when we use to go with, let's say if we choose to go with infrastructure as a service, in such scenarios this cloud service provider have this responsibility of physical infrastructure, space, power, cooling, internet and hardware, security of these infrastructure component, and ensuring that business continue and this customer service cloud service provider has this responsibility to ensure that business continuously get the resources or the hardware that they had paid for, right? And what the customer have the responsibility? So customer has this responsibility of operating system, patches, frameworks, runtime, application and the data and the security of these upper layer component, right? So now let's also talk about this platform as a service. So when we say like platform as a service, in such cases cloud service provider has this responsibility for infrastructure plus platform component. Okay, so that includes operating system, patches, frameworks, runtimes, security of these components and everything. Now what is the responsibility of the customer? This customer has the responsibility of managing the application and the data, security of the application and the data, right? So these two parts is now being managed by customer. Okay, so less work for the customer but slightly less control compared to infrastructure as a service, right? So the third part, we are let's say using this software as a service. Okay, so in such case, what responsibility this does this cloud service provider handles? So in such cases, that entire stack including this application, so I mean that's hardware part also and this software part also, both are being managed by cloud service provider itself, right? Ensuring that application is always up and running. So these have to be also ensured by the cloud service provider. Apart from this, the security of all the component except data, because in data there are also responsibility of this, the data part is also the responsibility of customer itself, right? So they have to maintain all the credential and they have to manage all the data because they have the credential and he is responsible for the security of the data, right? Like CSP is also responsible for the security of the data at the database end, right? But from that application point of view, customer has have the responsibility of securing the data, and do not have to share the credentials or misuse your credentials, like, or I mean, there are so many cases, right? So minimum effort of the customer, but least control. Okay, so in software as a service, customer do not have to do much, but still in this scenario the customer have a very least control. Okay, so what are the key takeaways? So in all the services model, you can see in all the service model, either a PaaS, IaaS, or SaaS, right? In all the three, customer is always responsible for the data, right? So understanding that shared responsibility model here, so in this case we so why we had understand here this shared responsibility model, because it avoid this misconfiguration. It ensured that the proper security practices must be followed, and the clear role in case of any issue, right? So here is a table. Like it is in table, you can simply go through if you required. So where this cloud provider, so managed by the cloud provider. So what is managed by cloud provider, what is managed by customer, what is managed control, customer control level, setup level, flexibility, idle for examples, and there are many more things. Okay, so basically what part of is managed by cloud provider. So in infrastructure as a service, all that physical infrastructure, which includes the server, storage, networking, power, cooling, everything is managed by the cloud service. In PaaS, platform as a service, infrastructure plus operating system plus patches plus frameworks plus runtime, all of these are managed by cloud service. Okay, but in SaaS application, this entire stack, which includes the application, both hardware part and this software part, both are managed by cloud service provider, right? So what is managed by the customer? So in IaaS, infrastructure as a service, this operating system, patches, frameworks, runtime, application data, all of these are managed by customer itself. In platform as a service, the customer is responsible for managing the application and data, right? But in case of SaaS application, the customer only have the responsibility of managing data, right? So let's say if we talk about the control level, so in IaaS application, infrastructure as a service application, customer have high control, like let's say you can say like full control of the environment. In PaaS application, we have medium control of the customer, and in SaaS application, we have a very low control of the application. That here at this level, that only control is of the data management, right? So let's say if we are just going to configure, try to understand at the point of let's the setup time. So here this IaaS, infrastructure as a service, it's longer setup time because it needs to require the configuration, because here you are configuring the operating system stacks, managing the security and everything, right? So here in PaaS application, this time is moderate, and in SaaS application, this setup time is minimal, right? So if we talk about this flexibility, so that infrastructure as a service has this maximum flexibility because it gives you the ability to customize your environment as per your requirement. In case of PaaS application, like PaaS service, we do not have much environmental control or the customization, so you can say it's balanced, right? But in SaaS application, you had this limited control or that limited flexibility to do anything, right? Next is to whom this SaaS application, this infrastructure as a service, IaaS services is good for. So if you want to create your custom application, you want legacy system, full control if you need. So in such case, you should go with IaaS, right? So if you are just a developer, you want to deploy your app, okay, and you need faster development cycle, in such case you should use PaaS application, like PaaS service, platform as a service. And if it is if you are the end user and you just your requirement is to do the business and increase the business itself, you do not want to get into this messy app development and the development cycle and the deployment and everything. So in such case you should go with SaaS application. It is available in the market, right? So what are the some of the examples of the different application that should offered by this under this IaaS, PaaS and the SaaS offered by the Azure. So this Azure virtual machine, AWS, EC2, so all of these are the examples of IaaS, right? So if we take the example of PaaS application, it is that Azure App Service, Google App Engine. So these are the application examples of this PaaS services. And these microservices, Microsoft 365, Salesforce, Gmail, and all of these are examples of SaaS application. In terms of cost management, so pay for the infrastructure use. So you will only pay for the infrastructure. Here you pay for the platform uses. And in third scenario, in SaaS application, you pay per user or the per subscription, right? And if in terms of security and responsibility, so here we have this shared responsibility. In all the three cases we have shared responsibility, but in infrastructure as a service, we customer have to secure the operating system and the above, right? So only that hardware part is managed by cloud, right? Cloud service provider. Instead in PaaS service, the customer have to here we also have this shared responsibility principle to be followed, but the customer has to only secure the app and rest all part is managed by customer, right? Sorry, this cloud provider. But in SaaS, all other part is managed by the customers, like cloud service provider, and that only part that is that needs to be required managed by the customer is the data of the application, right? Okay. So now we had understand all of these different services. Now let's try to understand this public cloud. Okay, so what is this public cloud? Okay, so a public cloud offers the computing services to the multiple customer organization over the public internet. Okay, the service are open to anyone who want to pay and consume them with minimal restrictions. Okay, so customer are refers to the tenant and as the rent computing resources from the cloud provider. Okay, so what services does it offer? So public cloud provides all the three services model, that is infrastructure as a service, platform as a service, and software as a service. Who use the public cloud? So on that so public cloud is suitable for the startups, small and the medium businesses, and the large enterprises. Okay, so for all of these these models are good to use. Okay, so so these models are designed for scaling and scale and serves diverse needs across the industries. Okay, so if your requirement is such that that is fulfilled by IaaS, you should go with this. If it is if your requirement is fulfilled by PaaS, right, PaaS, then go with this. And if your requirement is fulfilled by software as a service, go with that one, right? So all of these public clouds are basically cost efficient. So public clouds provides the providers operates on low cost high volume strategy. They makes the public cloud economical and accessible. So multi-tenant expand on. So let's try to understand this. What is this multi-tenancy explained? Multi-tenancy. So multi-tenancy means multiple customers shares the same physical infrastructure. Each tenant gets the dedicated virtual resources, and thanks for the virtualization. Okay, so all of these are being possible because of this virtualization, right? So security is in the public cloud. So how this security is managed? So virtualization ensure the isolation. So your virtual resource and the data are dedicated and secure, right? Even the cloud providers cannot access your data, right? So this is what we call as virtualization, right? So it ensures your isolation. The second point is additional security controls are in place to protect the tenant data. And the third point is security is governed by the shared responsibility model. So cloud provider secures the infrastructure and customer secures the data and the configuration, right? So now we have some key characteristics of the public cloud. So what are the key characteristics? If someone going to ask you, like list the key characteristics of public cloud or these cloud providers, so you can say this, all of the four characteristics applies there. This is resource pooling, this elasticity, pay per use, and automation. So these are the four characteristic of public cloud which we had already discussed, right? Okay, so we will cover this private cloud in our next video. Okay, so for now I am like even getting some tired and I need some water, so I'm going for that, right? So this private cloud will be take this private cloud part and the other rest will be taken care in our next video. Okay, so for now I'm just going. Till then, if you have any question, you can ask me in the comment section, right? And I can definitely gonna answer you. So for now, I'm just dropping off. Okay, see you in the next video. Till then, have a nice day and goodbye.